This section is about cells and batteries, and I think that in this picture we can all identify with Dwight. Batteries are an example of electrical technology that we rely so heavily upon, and this section is we are just a little bit of an introduction on cells and batteries, so we're going to learn a little bit about how they work. Here are some important applications for cells and batteries. Of course, from the previous slide and from our own experience, cell phones are vital for our communication and just our lifestyle, the way we live. Some other vital applications that you might not know about, or if you do, is a pacemaker. So what a pacemaker is, um, it's it's a device that will help people regulate their heart rates and keep it normal. Some people suffer from something called arrhythmia, so I'll try to write that out for you here. Arrhythmia. Oops, arrhythmia. And that just means that that's supposed to be, yeah, it's 2 R's. Yeah, it is 2 R's. That just means that the rhythm of your heart is abnormal. So it's either beating too fast or too slow. Those conditions can be fixed with some medications, and some arrhythmias are inconsistent, so the heart can be beating really fast and for a few seconds, then really slow. And the natural mechanism by which um, I won't go too much into it. That's supposed to be a heart, by the way. The natural mechanism that occurs is somewhere up here. It's called a natural pacemaker right there. Oops, sorry. I'm trying to get used to this. So there's a natural pacemaker right there, and then below it is another sort of pacemaker over there, and these two communicate to regulate the um, the rhythm of the heart. Well, sometimes this first one doesn't work. Now, if that one doesn't work, then um, or I'm not too sure which one, to be honest. It's one of these two that don't work when it comes to pacemakers. And then so they just need this device installed in their chest to help regulate their heartbeats, and they are powered by batteries. So that is very important. So two things we need to differentiate here. There are two primary electrochemical cells. One's called a dry cell, and the other one is called a wet cell. A dry cell is dry because there is no liquid in it. A wet cell is called a wet cell because there is a liquid in it. We'll talk more about that later. The other thing we need to know about is the difference between a cell and a battery. A battery is, the word that we typically use every single day in our, in our everyday speech. But for science, we need to know the difference between cells and batteries. And I always find that the easiest way to explain it to students is by just going into the schematic drawings right away. So later on, when we start drawing circuits, we're going to learn how to draw circuits two ways. We're going to learn how to draw circuits with the actual elements in our drawing. So for example, a light bulb, and we'll draw a light bulb, and then we'll draw a battery, we'll draw a wire. But another way of doing it is called schematic drawing. So people that are in the field, when they're drawing complicated circuits, they're not going to draw every single thing the way it is in real life. They're going to come up with symbols that represent them. So for example, if I do this, right, well, this is an example of a very simple circuit, okay, and it's a schematic drawing. Oops, not perfect, but good enough. So this part of the circuit here that I'm tracing out is representative of the wire. This squiggly line is representative of a resistor. This is the symbol for a resistor. This here is the symbol for a cell. Okay, that is a cell. And the symbol for a battery would be this. So there's a difference between a cell and a battery. In other words, a cell is made up of just one object that can provide electrical current, electrical power, electrical voltage to a circuit. A battery is two or more of these. So as soon as you see two or more cells, it's called a battery. A cell is just one. And we will learn about this later, but this side is denoted as a negative side, and this side is denoted as the positive side. Okay, let's move on. So what is an electrochemical cell? An electrochemical cell is a package of chemicals designed to produce small amounts of electricity. The electricity the cell produces comes from chemical reactions and supplies a steady current. So it is useful because it is current. It's not static electricity that's produced, it's current. So it is useful. Okay, so what is a dry cell? We talked about that earlier. A dry cell is called a dry cell because something called an electrolyte, which we'll learn in the next slides, is a paste. So chemicals that are used to drive the current are in paste form. So the good thing about it is that if it's not wet, it doesn't really leak out. A common example is the alkaline dry cell that we use. So the way it works, and you'll watch videos about this, is that chemical reactions will release free electrons from the metals involved in the chemical reactions, and these electrons will travel through negative terminals, negative electrodes, and through the device, that whatever you're hooking your battery or your cell to, and then it goes back to the positive terminal, and then that is what drives or causes devices to function. So what's an electrolyte? Well, an electrolyte is either a paste or a liquid, depending if it's a dry cell or if it's a wet cell. And it conducts electricity because it contains chemicals that form ions. Remember, ions are positively or negatively charged forms of atoms of elements. Okay, so that's from our Unit B, our chemistry. Okay. Oops. So what is an electrolyte and what does it react with? So I'm just going to draw a simple wet cell for you. Okay, so here's a very crude diagram of an electrical cell, and this is what's called a wet cell. It's a very simple wet cell. Okay, because it's wet. It has a liquid here. So this green part that I shaded in for you is the liquid that is, that the two electrodes, these are electrodes again to that, are submerged in. This liquid portion is called an electrolyte. Okay? In a wet cell, the electrolyte is a liquid. Okay? And it is typically an acid, and a common example is sulfuric acid, or H2SO4 aqueous, and this is what's found in car batteries. So your car battery is made up of many different wet cells. Okay? Wet cells are typically more dangerous than dry cells, but they're easier to make. So we'll go through the parts of the wet cell. I already went through the first part here, which is the electrolyte. And then the other two parts are the electrodes. So the electrodes are zinc. This is one electrode here, zinc, right? That I colored in red. And the other electrode is copper, which I colored in yellow. Okay? So what's happening here is that the zinc and copper have independent chemical reactions happening with sulfuric acid. So zinc is reacting with the sulfuric acid, and copper is having its own chemical reaction with the sulfuric acid. What's happening at this electrode here is the sulfuric acid and the zinc react in such a way that we have an accumulation of electrons. So we got electrons kind of building up here at this side, this electrode. Okay? And what happens here, the nature of the chemical reaction between copper and sulfuric acid leaves the copper electrode positively charged. So there you see it, right there. We have negatives on one electrode and positive on the other electrode. So what happens is there is a difference in charge that is created by these chemical reactions. That is the potential difference. Okay, in other words, this difference will then drive electrons to leave, to travel through the zinc electrode, through the wires, okay, through the wires going this way, through whatever device you have there, and this is supposed to be a schematic symbol of a light bulb, okay, and then the electrons will travel back through the wire and go to the copper because opposites attract, okay, and so that is an electric current, and that will cause this light bulb to light up. There we go. Okay, so it is a current electricity. It is useful, not static electricity. Okay, so current electricity is created here. So this zinc here, another thing I do want to introduce to you is because we have a negatively charged buildup, this is called the negative electrode. Okay, so it's a negative, part of my printing, electrode. Yeesh, Lord have mercy. Okay, that says negative electrode. Okay, and the negative electrode is called the anode. Okay, so that means copper is the positive electrode, and it is called the cathode. So electrical current will always go from the direction from the anode to the cathode. Okay, so it goes from negative to positive. So what is the difference between a primary cell and a secondary cell? Primary cells they produce electricity from chemical reactions that can't be produced. So this is an example of what happens inside your Duracell battery. So it happens there, and you can't recharge the battery after it's run its course, its chemical reactions, it's done. Secondary cell is a rechargeable cell. The chemical reactions can be reversed by using an external electrical source to run electricity back through the cell. The reverse flow of electrons restores the reactants that are used up when the cell produces electricity. Examples, laptops and cell phones, we can charge our batteries. So secondary cells have chemical reactions that can be reversed. Okay. An external energy source runs electricity back through the cell. So the electrical current is reversed. Okay. This reversal of electrical current reforms the electrodes. Okay, and so that means that the electrodes are formed back again. That means they have the metal are kind of rejuvenated in a sense, and then the battery can be hooked up again to be used. Okay, it wears out with time because electrodes are imperfect with every single charge. So that might be an example of an electrode when it's fresh, when it's brand new, and then over time, when you use it, it gets depleted and it looks like that shorter, right? All this is gone, it's involved in a chemical reaction. But when you reverse the current, what happens is we get it back, but we notice that, it's not as nice and crisp and clean as the original one here, right? So over time, secondary cells lose power. I'm not going to go over this. This is not supposed to be here. This is in your notes for remote learning, so you can go work through that. Another thing I want to talk about is electrolysis. Electrolysis is used to separate useful elements from solutions. So here is an example of what electrolysis would look like in real life, and this here is an example of a practical application of it. So this is part of a motorcycle, and the metal pieces are electroplated with chromium. Okay, and they call it chrome plating because the chromium protects the metal on the motorcycle parts and protects it from rust, and it actually gives it a nice pretty shine and it looks pretty sharp. That's a practical application of electrolysis, electroplating, and this is how it looks in real life there. So I'm going to go over electroplating very quickly. Electroplating, a metal that is to be covered, is placed in the electrolyte. So there is the metal that's going to be covered. Another metal that will be used to coat the first metal is also placed into it. So here's the metal that's going to coat the original metal. Okay. These two metals act like electrodes in the previous electrochemical cell that we talked about. The difference between this and the previous electrochemical cell we talked about, that simple cell, is this right here. If I can draw a circle around, it's not working. Is this part right here. Okay? You hook up an external source of current to this, and then electrons go through the metals, and because the batteries, or the battery of the cell, depending on how many there are connected to the electrodes, and the flow of electricity will cause metal atoms to be coated from this metal, right, this metal here, coated onto this metal. Okay, so the source of the metal is always going to be your positive electrode. Some other applications here, galvanizing and electrorefining are some other practical uses as well. And here are some important points to remember from this presentation. Dry cells or chemicals are in a paste, they're sealed, the chemicals don't leak out. We can use them in things like flashlights, cell phones, laptops, etc. Wet cells use a liquid electrolyte that's usually an acid, and many of the earliest cells were wet cells, and they're used in vehicles for battery, for example, our cars. Okay, that went on a little longer than I wanted to, but hopefully that will help.